Hello, welcome to AmoyDiagnostics. This video is about AmoyDx BRCA Pro Panel Assay procedure. AmoyDx BRCA Pro Panel. The kit contains HS probe, HS hybridization buffer, HS extension ligation master mix, HS Exonuclease A, HS Exonuclease B, HS PCR master mix, HS S5 primer, HS N7 primer, HS positive control, and HS negative control. Halo shape annealing and defer ligation enrichment system technology. The AmoyDx BRCA Pro Panel is a next-generation sequencing-based in vitro diagnostic assay. Overall, 6 steps are required. Reagents for each step are in tubes labeled with different labels. For pre-denaturation step, TE low solution is required. For hybridization step, 2 reagents are required, HS probe and HS hybridization buffer. HS extension ligation master mix is used for extension and ligation. HS Exonuclease A and HS Exonuclease B are used for Exonuclease digestion. After Exonuclease digestion, a PCR amplification step is performed to enrich the target libraries. The AmoyDx BRCA Pro Panel provides a total of 96 combined barcodes for 96 samples parallel sequencing with 8 HS S5 primer and 12 HS N7 primer. It is recommended to use Agincourt AM-Pure XP beads for library purification to remove residual extra primers and reagents. Library quantification and size distribution measurement are needed prior to sequencing. It is recommended to include an HS positive control and an HS negative control in the process of library preparation, sequencing, and data analysis. Materials and instruments preparation. Filtered pipette tips, Sharps container, 0.2 milliliter and 1.5 milliliter nuclease-free centrifuge tubes, tube rack, 0.2 milliliters and 1.5 milliliters ice box, powder-free latex gloves, marker, vortex mixer, palm centrifuge, magnetic stand, pipettes, timer, ABI 2720 PCR instrument. AmoyDx BRCA Pro Panel. Nuclease-free water. Absolute ethanol. 1 times TE. AM-Pure XP beads. Specimen preparation. It is recommended that the FFPE tissue sample should be fixed by 10% neutral buffered formalin for 6 to 24 hours. The freshly cut sections of FFPE tissue should be used for DNA extraction immediately. The storage time for the FFPE tissue should be less than 12 months. The tumor cell content is no less than 20%. The DNA concentration should be more than 3.75 nanograms per microliter, and the total DNA should be more than 30 nanograms. The peripheral whole blood should be more than 2 milliliters. The EDTA anticoagulant is recommended during the blood collection. Avoid using hairpin anticoagulant. The blood sample should be extracted immediately or transported at 2 to 8 degrees Celsius. If not, store the blood sample at -20 plus or minus 5 degrees Celsius for no more than 3 years. The DNA concentration should be more than 3.75 nanograms per microliter, and the total DNA should be more than 30 nanograms. For unqualified samples, recollection or re-extraction are required. Assay procedure. Pre-denaturation. Take out the DNA samples, HS positive control, HS negative control, and TE low solution. Thaw the reagents at room temperature. When the reagents are completely thawed, mix well on the vortex mixer and centrifuge briefly. Then keep the tubes on ice. Assemble the pre-denaturation reaction on ice by adding the components according to the table on the left. For FFPE tissue samples, add 3 to 100 nanograms DNA. For blood samples, add 30 to 50 nanograms DNA. For PC or NC, the DNA concentration is 6.25 nanograms per microliter. Take 8 microliters to construct library. Mix the solution thoroughly by vortexing or pipetting, and centrifuge briefly. Then place the sampler in the thermocycler. Set the reaction volume as 8 microliters and perform the following program. 98 degrees Celsius for 5 minutes, then put the tubes on ice immediately. Please perform the subsequent hybridization step immediately when the reaction is finished. Hybridization. Take out the HS probe and HS hybridization buffer and thaw the reagent at room temperature. When the reagents are completely thawed, mix well on a vortex mixer and centrifuge briefly, then keep the tubes on ice. Take out the above pre-denaturation product from the thermocycler and keep the tubes on ice. Assemble the hybridization reaction on ice by adding the components according to the table on the left. Add 1 microliter HS probe and 1 microliter HS hybridization buffer. Mix the solution thoroughly by vortexing or pipetting and centrifuge briefly, then place the sample in a thermocycler. Set the reaction volume as 10 microliters and perform the following program. 95 degrees Celsius for 5 minutes, 60 degrees Celsius for 2 hours, 4 degrees Celsius, hold. Please keep the tubes at low temperature after hybridization is finished, as high temperature like room temperature may increase the non-specificity. It is recommended to place the icebox besides the thermocycler, and when it is finished, take out the reaction tube and put it in the icebox immediately. The hybridization products should be stored at 2 to 8 degrees Celsius for no more than 20 hours. If not, proceed to the next step. Extension ligation. Take out the HS extension ligation master mix and thaw the reagent on ice. When the reagents are completely thawed, mix well on a vortex mixer and centrifuge briefly, then keep the tubes on ice. Next, take out the above hybridization product from the thermocycler and keep the tubes on ice. Add 1 microliter HS extension ligation master mix into the PCR tube. Mix the solution thoroughly by vortexing or pipetting and centrifuge briefly. Then place the sample in a thermocycler. Set the reaction volume as 11 microliters and perform the following program. 60 degrees Celsius for 10 minutes, 4 degrees Celsius, hold. Perform the subsequent exonuclease digestion step immediately when the extension ligation step is finished. Exonuclease digestion. Take out the HS exonuclease A and HS exonuclease B. Mix well on a vortex mixer and centrifuge briefly, then keep the tubes on ice. Then assemble the exonuclease digestion reaction on ice by adding the components according to the table on the left. Add 1.5 microliters HS exonuclease A and 1 microliter HS exonuclease B. Mix the solution thoroughly by vortexing or pipetting and centrifuge briefly. Then place the sample in a thermocycler. Set the reaction volume as 14 microliters and perform the following program. 37 degrees Celsius for 30 minutes, 95 degrees Celsius for 10 minutes, 4 degrees Celsius, hold. Please store the products of exonuclease digestion at 2 to 8 degrees Celsius for no more than 20 hours. If not, proceed to the next step. PCR amplification. Take out the HS-S5 primer, HS-N7 primer, and HS-PCR master mix, and thaw the reagents at room temperature. When the reagents are completely thawed, mix well on a vortex mixer and centrifuge briefly, then keep the tubes on ice. Assemble the PCR amplification reaction on ice by adding the components according to the table on the left. Add 25 microliters HS-PCR master mix, 1.5 microliters HS-S5 primer, 1.5 microliters HS-N7 primer, and 8.5 microliters PCR grade water. Use different combinations of HS-S5 primer and HS-N7 primer for each sample library. Do not use the same combination of index for 2 or more sample libraries in one sequencing run. Transfer the prepared tubes to the amplification room to perform PCR amplification and the following purification to avoid contamination. Mix the solution in each PCR tube thoroughly by vortexing or pipetting and centrifuge briefly. Then place the sample in a thermocycler. Set the reaction volume as 50 microliters, and then perform the following program according to the table on the left. The PCR product should be stored at 2 to 8 degrees Celsius for no more than 20 hours. If not, proceed to the next step. Purification. Take out the AM Pure XP beads or clean NGS magnetic beads and equilibrate them to room temperature for 30 minutes. Prepare 80% ethanol. Take out the PCR amplification product from the thermal cycler, vortexed and mixed well, and centrifuged quickly. Add 40 microliters PCR products into a clean 1.5 milliliter centrifuge tube. Please note that the PCR reaction volume is 50 microliters, and 40 microliters PCR product needs to be accurately pipetted for purification. Then vortex the bottle of the beads to resuspend any magnetic particles that may have settled. Add 37 microliters beads into a clean 1.5 milliliter centrifuge tube. Mix thoroughly by vortexing or pipetting, then incubate for 5 minutes at room temperature. Place the centrifuge tubes onto the magnetic stand for 3 to 5 minutes until the solution turns clear. Gently remove and discard the supernatant while the centrifuge tube is on the magnetic stand. Do not touch the beads with pipette tip. Keep the tubes on the magnetic stand. Add 200 microliters of freshly prepared 80% ethanol to the tube. Incubate at room temperature for at least 30 seconds and then carefully remove and discard the supernatant. Repeat the last step. Briefly spin the tube and put the tube back in the magnetic stand. Use a P20 pipette to remove and discard any residual ethanol from the bottom of the tube. Completely remove the residual ethanol and air dry the beads for 2 to 3 minutes while the tube is on the magnetic stand with the lid open. Do not over dry the beads. This may result in lower recovery of DNA target. Elute DNA target from the beads by adding 30 microliters TE-low solution or 10 millimolar tris solution. Mix thoroughly by vortexing or pipetting and incubate for 3 minutes at room temperature. Briefly spin the tube and put the tube in the magnetic stand for 3 to 5 minutes until the solution turns clear. Without disturbing the bead pellet, transfer the supernatant into a clean 1.5 milliliter centrifuge tube to obtain the final library. The purified library should be stored at -20 plus or minus 5 degrees Celsius for no more than 2 weeks. If not, proceed directly to sequencing. Library concentration QC. Quantify the DNA library concentration using qubit fluorometer or QuantiFluor. For tissue DNA library, the concentration should be no less than 5 nanograms per microliter. For whole blood DNA library, the concentration should be no less than 10 nanograms per microliter. Otherwise, the library concentration QC fails, the library should be reconstructed. If the tissue DNA library concentration is less than 5 nanograms per microliter, or whole blood DNA library concentration is less than 10 nanograms per microliter, please first check whether it is caused by poor quality of the sample DNA or operating errors and try to repeat the test. If it's caused by the poor quality of the sample DNA, and it is recommended to extend the hybridization time and perform overnight hybridization to rebuild the library or recollect and retest the sample. Library fragment size QC. Assess the library quality on an Agilent bioanalyzer DNA chip or eGel PowerSnap electrophoresis system. The main peak size of the DNA sample, positive control, negative control library should be at 250 to 400 BP with no obvious small and large fragment peaks. Otherwise, the library concentration QC is unqualified. The library should be reconstructed. Sequencing. If the library QC pass, then move to sequencing. If not, sequencing is not recommended. The library should be reconstructed. Illumina 300 cycles, and the matched reagents and instruments are recommended for the sequencing. The denaturation and dilution of the library before sequencing should refer to the instruction manual of the corresponding sequencer. The final library concentration is shown in the table, with the sequencer and corresponding final concentration as listed. It can be adjusted appropriately according to actual experience of the laboratory.